Long before we had all the neural networks and large language models that we talk about today, there was a totally different kind of artificial intelligence that was supposed to change the world. Seriously, they were AI's first real superstars. And then, poof, they just vanished. So today, we're going to peel back the layers on this forgotten revolution of expert systems and figure out what in the world happened. Okay, so check this out. What you're looking at is a Lisp machine from back in 1984. This was a beast, a super specialized, high-powered computer built for one thing, running the AI of its time. And the whole promise, the big idea was that this machine and its software could literally put a human expert's brain inside a box. I mean, this was the future, which leads to the big question we're tackling today. Where did that future go?
All right, to really get to the bottom of this mystery, we've got to jump in the time machine and head back to the 1980s. Because you need to understand, this wasn't some little project tucked away in a university lab. Oh no, this was a full-blown corporate phenomenon that was taking over the biggest companies in the world.
Yeah, you heard that right. During the boom of the 1980s, an absolutely mind-blowing 2/3 of Fortune 500 companies were using these things they called expert systems. And this technology was everywhere. I mean, we're talking manufacturing, finance, even medicine. This was one of the first times AI wasn't just a theory, it was a real, successful commercial product. So what was this revolutionary technology exactly? I mean, how on earth did they capture the knowledge of a human expert and actually put it inside a computer? Well, at its heart, an expert system pretty much does what the name says. Instead of being programmed with step-by-step instructions like normal software, it was designed to solve really complex problems by reasoning. It used a big body of knowledge, kind of like a human would. The whole goal was to build a machine that could make decisions just as well as a top expert in, I don't know, medicine or geology. And the way they did this was actually kind of beautifully simple. It had two main parts. First, you've got the knowledge base. You can just think of this as the system's library. It's filled with tons of facts, and this is the key part, a whole bunch of if-then rules that were carefully pulled from the brains of human experts. Then you've got the inference engine. This is the system's brain. Its job is to take all those rules from the library, look at the facts of a new situation, and figure out what to do next. And this quote right here, it really gets to the heart of the whole breakthrough. Edward Feigenbaum, who's basically known as the father of expert systems, he argued that the real magic wasn't in how the computer thought, the inference schemes or whatever. Nope. The real power came from the knowledge it had. The secret sauce was figuring out how to get what an expert knows into a format the computer could use. Okay, so we've got the brain. That's the inference engine. And we've got the library, the knowledge base. But how did that brain actually, think? How did it connect the dots between the rules and the facts to spit out an answer? Well, that inference engine, the brain, it mostly used two different ways of thinking. The first is called forward chaining. This one is all about the data. You basically just give the system all the facts you have, and the engine chugs forward through its rules to see what it can figure out. The other way is backward chaining. This one's goal-driven. It's like being a detective. You start with a hunch, a possible conclusion, like does this patient have this specific disease, and the system works backward to see if the clues, the facts, actually support that theory. Let's make that a little more concrete with a super classic logic example for forward chaining. Okay, so first, you tell the system a rule. All men are mortal. Got it? Then you give it a fact. Socrates is a man. The inference engine sees that, connects the dots, and automatically adds a brand new fact to its library. Therefore, Socrates is mortal. See? Simple, logical, and actually really powerful. And here's a fantastic everyday example of backward chaining. Let's say our goal is make $20. The system looks for a rule that ends with that result and finds one. If you mow the shaggy lawn and wash the dirty car, then you get $20. So it starts working backward from the goal. First check, is the lawn shaggy? Yes. Okay, next check, do we have a mower? Yes. Next, is the car dirty? And so on. It just breaks a big goal down into a checklist of smaller yes or no questions. So, with this powerful new way of thinking, it's no surprise that expert systems just exploded onto the scene. They were everywhere. But you know how these things go. Like a lot of big booms, this one was followed by a bust. Or maybe it wasn't. This timeline really shows the wild ride these systems went on. They first show up in the mid-60s, then hit their absolute peak in the 80s. That was the boom we talked about. But then you get to the 90s, and the term expert system, it just vanishes. Gone. It got tangled up with the AI winter, which was this period where nobody wanted to fund or even talk about AI. But then, something weird happens. In the 2000s, a technology that looks and acts almost exactly the same pops back up, but with a new name: rule-based systems. And that brings us right back to our big mystery. Did this amazing technology just die? Was it all a bunch of overblown hype? What really happened to AI's first superstars? Well, there are basically two competing stories about what went down. Theory number one is that they just failed. Simple as that. The hype got way ahead of the reality. It was super hard to actually get the knowledge out of experts, and plugging these things into existing companies' software was a nightmare. So the world just moved on. But then there's theory number two, which is the complete opposite. It says that expert systems were so successful, so incredibly useful, that their core ideas just got sucked up into mainstream software. They didn't die, they became invisible. So which one is it? Did they fail, or did they become invisible? Well, it turns out the second theory is much, much closer to the truth. The spirit of the expert system is absolutely still with us today. It's kind of like a ghost in the modern machine. Yeah, they didn't die. They evolved. They became so fundamental, so much a part of the basic toolkit for programmers that we just stopped giving them a special name. What was once a revolutionary idea just became another tool in the toolbox. And I'm serious, once you know what to look for, you can see their DNA everywhere today. Remember that inference engine, the brain of the system? We just call that a business rule engine now, or a BRE. And it's the beating heart of all kinds of systems that automate complex business stuff. Those huge software suites from companies like SAP and Oracle, they're packed with these rule-based systems to handle all their complicated logic. They're the invisible engines running inside everything from automated medical diagnostic tools to the financial software that moves money around the world. So yeah, they didn't disappear. They just went out and got a job. And all this brings us to a final, and I think really important question for right now. I mean, we are living through another massive AI boom, right? And the story of expert systems, it gives us a powerful lesson for how to think about it. It teaches us that hype, well, hype comes and goes, but real usefulness, that sticks around. The most revolutionary technologies aren't always the ones grabbing all the headlines. Sometimes they're the ones that quietly work their way into everything, becoming so essential that we completely forget they're even there.